Hey, what's up everyone? I hope all of you are doing great. And in today's question, we have a horizontal disk of mass 1 kg mounted on a fixed vertical axle through its center can rotate without friction. So the whole disk is mounted on an axle passing through O, so it can freely move with respect to this axis. A small ball B of mass 1.5 kg when pushed on the disk towards the center O. Okay, so this ball is pushed towards the groove. Actually, the ball enters the groove with a speed of 2 meter per second and moves through the groove without friction. With what speed will the ball lift the disc? Neglect loss of mass, cutting due to the groove. Which one of the four options are correct? Okay, so let us analyze the situation once again. So there is a semicircular groove, there is no friction anywhere. This ball is thrown with an initial speed of 2 meter per second. It enters the groove. While entering, it tries to perform the ball tries to perform a circular motion by keeping this point O prime as the center. Now, while performing circular motion, it always applies a normal force away from O prime. Hence, performing or providing a clockwise torque on the disc due to this normal. Hence, the angular velocity of the disc starts increasing, okay, in the clockwise sense. Now, when the ball reaches the other end of the groove and tries to come out of the groove, the disc has already gained some angular velocity omega. Okay, so the initial kinetic energy of the ball is utilized to increase the angular velocity of the disc, and final speed of the ball becomes v. Okay, so this speed, this v, is the velocity of the ball with respect to ground. Okay, so first we need to conserve the kinetic energy, that is the initial kinetic energy of the disc, that is half mass, the initial kinetic energy of the ball, that is half mass of the ball, that is 3 by 2 times 2 square, is utilized to increase the kinetic energy of the disc, that is half I omega square. What is I here? I is mass of the disc, radius square divided by 2, because mr square by 2 times omega square, plus the final kinetic energy of the ball. Okay, so initial kinetic energy of the ball, final kinetic energy of the ball, and final kinetic energy of the disc. Let us simplify this one. So we have 3 r square omega square divided by 2 plus 3 by 4 v square. We are interested in v here. In our question, they have asked for v. So we need another equation, and we will get that equation by conserving angular momentum with respect to point O. So with respect to point O, the whole structure will have an initial angular momentum 0, because the disc was not rotating at all, and with respect to point O, this mass or this ball will have an initial angular momentum 0, because it passes through the point O itself. Fine. Now the final angular momentum will be due to the rotational motion of the disc, that is I omega, and mvr due to this one. So with respect to point O, initial angular momentum was 0, final angular momentum will be I omega plus, or actually minus, mvr. So I is moment of inertia of the disc, that is mass of the disc, radius square divided by 2 times omega, minus mass of the ball, v times r. So r gets cancelled out, so we have r omega equals 3v. So we will just put the value in the first equation, then we will get 3 equals to 9v square divided by 2 plus 3 by, here it will be 4 actually, because 2 times 2 will be 4. So we have 9v square divided by 4 plus 3 by 4 v square. So we have 4, 12, 3v square. So v equals to 1 meter per second. So the final speed of the ball just when while coming out of the groove will be 1 meter per second with respect to the ground. Okay, so option A is correct. So I hope you all have found this video helpful and informative, and if you are new to this channel, please do subscribe. If you like the video, please give a thumbs up. Okay, and I will see you in the next one. Good luck, peace.